All right, we just finished going over our distribution homework, and I'm going to begin teaching you how to factor. This is our first lesson on Teach Me How to Factor. Let's go to work. Let's start by taking some notes, and I'll show you some examples. Okay? We are going to be factoring quadratics. Factoring quadratics. You want to write all of this down. In other words, teach me how to factor. Okay, teach me how to factor. Reminder, quadratics are expressions to the second degree. Okay, their graph is a parabola. I want to remind you of the two forms that we've already dealt with, and that is standard form and intercept form. Standard form is ax squared plus bx plus c. We've already dealt with that so far. You guys have memorized them and put them on, done well on your quizzes. Boy, that probably is going to come back somewhere sometime soon. Hint, hint, hint. And also intercept form. Intercept form is also known as factored form. Remember, it was a times x minus p times x minus q. What we're going to do today is basically we're going to take quadratics that are in standard form, and we're going to change them or manipulate them and put them into intercept form or factored form. See, this allows us to, when it's in intercept form or factored form, it allows us to see our x-intercepts quickly. Remember, our x-intercepts are opposite of what we see, just like we see in the formula. We're going to use the opposite, okay? But we'll come back to that in a minute. The factored form allows us to see our zeros or our roots or our solutions. Remember, those all mean the same thing. X-intercept, zero, root, solutions all mean the same thing. So when we go to factor quadratics, the first thing we're going to do is GCF. We're going to find our greatest common factor. I want to remind you of our greatest common factor. I've got two examples for us right here, 2x plus 4 and then 3x squared plus 6x plus 9. We're going to start by finding the GCF. What is the GCF of 2x plus 4? Yep, that's right. It's 2. So I can pull out a 2. 2 times what gets me 2x? Well, 2 times x. And 2 times what gets me 4? Well, 2 times 2. So there, I just factored a 2 out of 2x plus 4. Everybody see how that was done? Let's do the second one. What can I factor out of the second one? Don't everybody speak at once. What's the GCF? What number goes into 3x squared plus 6x plus 9? And everybody said 3. Yes, so I can pull out a 3. So now, basically, remember, when I'm finding a GCF or what I'm factoring out, I'm really dividing, right? How many times does 3 go into 3x squared? Well, it goes in x squared times. Or what times 3 gets me 3x squared? How many times does 3 go into 6x? 2x. How many times does 3 go into 9? 3. See, we just factored out a 3. Okay? And that's what we want to do the first time, every time. You should look for a GCF. That's something everyone should know. Okay? You want to start with a GCF. Now, can you factor things without taking out a GCF? Yes, you can, but it's very difficult. It's very, very difficult. Okay? So the very first thing we want to do is look for a GCF. After we determine that there's no GCF, which all the ones we're going to be dealing with here for a while are not going to have a GCF, okay? Why? Because we're going to say, hey, is there a leading coefficient? I'm going to erase this and I'm going to write it again. All right. Is there a leading coefficient? If your answer is no, there's no leading coefficient. These are the ones we're going to do today. You will go right to split and signs. Split and signs. Okay? Once you've split the signs, you'll list the factors of the constant. I'll show you what all that means here in a minute. Later this week, I'm going to teach you the second half of this. And that is, what if the answer to, is there a leading coefficient? What if that answer is, why, yes, there is. If your answer is yes, you will learn the box method. Okay, you will learn the box method. But I'm not going to teach you that till later this week. Cool? Whoa. Whoa. Where'd you go? Time out. All right, I think we found it. Okay, so I'll teach you the box method. Whew, glad y'all missed that. That was scary. Okay, let's try. Let's go to work a little bit. Let's try it here. Yeah, missed me screaming on camera. It's okay. So the first thing we're going to look for is this: is there a GCF? But all the ones that we're going to deal with for right now are not going to have a leading coefficient. And so if they don't have a leading coefficient, they're not going to have a GCF. If your leading coefficient is 1, the largest number that could go into all of them would be 1. So it's not going to have a GCF. So I'm going to ask you, what's the first thing you look for? You're going to say GCF, even though we're not going to have one for a while, at least not today. Okay, so the first thing we should look for is a GCF. That's something everyone should know. This first one we're dealing with right here does not have a GCF. Okay, now, next question. Does it have a leading coefficient? No, it has no leading coefficient. So since it has no leading coefficient, the first thing we should do is split in signs. What split in signs means is we're going to put 2 sets of parentheses down here, and we're going to put an X in each. Then we're going to look at the last sign. Always start by looking at this last sign. And you remember last week when I wrote this stuff down, I put same plus and opposite minus. You guys remember that? Well, that comes back into play here. When I look at this last sign, I see it's a plus. I know that both signs inside my parentheses are going to be the same. I don't know if they're both positive or both negative, but I do know that they're going to be the same. Then I look at this sign in the middle, and I see that it's positive. Therefore, both of my signs down here will be positive. That's what I mean by split in signs. Everybody okay with that? Then finally, I'm going to list the factors of the constant. Well, 12 is my constant. The factors of 12 are 1 and 12, 2 and 6, 3 and 4. Which of those come together to get me a 7? 3 and 4. 3 and 4. I put those 2 in those 2 open slots. Boom. I'm done factoring. Well, that wasn't so bad, was it? Wasn't so bad. Okay. Epic. Okay. I mean, it was good, but I don't know that I would call it epic. Let's try the second one. Let's try this one right here. Okay. X squared minus 2x minus 10. First of all, is there a leading coefficient? No. Well, I apologize. I skipped one, didn't I? Is there a GCF? No. Is there a leading coefficient? No. So, split in signs. Please pay attention. I put an X in each. Then I look at this last sign. What does it tell me? Signs are going to be opposite. See, it doesn't tell me positive or negative. This last sign tells me whether it's going to be the same or opposite. Does everybody understand that? Okay, this tells me then these are going to be opposite. So since they're opposite, I can go ahead and put a plus and a minus. Now, I can list my factors of 10. 1 and 10, 2 and 5. Is that it? Yeah, that's all the factors of 10. Which of those come together to get me a middle number of 2? None of them, right? That's a real thing. This is called not factorable. And that does happen. Not very often, but it does happen. Now, doesn't mean there's not any solutions or anything like that. What it does mean is it doesn't cross at one of our lattice points that we like. There are other things that we'll be able to do with these later, but for right now, if those two numbers don't come together to get me the middle number, it's not factorable. And you can just go NF. Cool? Let's move on. Let's do another one. First thing we should always look for is there a GCF? No GCF, okay? Now, look at this one. I put f of x equals that. Is that okay? Could I have put y equals x squared minus 8x plus 16? Could I have put, could I have put 0 equals? Yes. Yes, I could. Okay. Matter of fact, that's the way it is most of the time. Okay. I'm just showing that to you now because if there was how about if I had a 5 equals? Well, if there was some other number other than 0, I would actually have to subtract 5 from both sides to get x squared minus 8x plus 11 because I want it to be equal to 0. Are you with me? Well, why do I want it to be equal to 0, Coach Herman? Because what I'm trying to find are my zeros. My zeros. What's another name for zeros? Solutions. What's another name? Roots. What's another name? X-intercepts. Remember, all of those mean the same thing. That's why I just wanted to point out that these babies could be equal to 0. They should be equal to 0. What? Did I spell zeros wrong?
Is that how it's supposed to be? Is there supposed to be an E? No. It's zero. Yeah, I thought it was a Z.
Let me ask this. How do you spell heroes?
I don't know, but zeros aren't heroes. Why are they spelled the same?
Zeros are my heroes.
Oh, that sucks.
I don't know if I spell right or not, but we're going to go with it. All right. Yeah, I'm a math teacher, not an English teacher. All right. You know what? I'll be an English teacher for a second. I like it that way, so that's the way we're going to spell it. All right. Anyway, back to the problem at hand. We're factoring this one. Is there a GCF? No. Is there a leading coefficient? No. So, and everybody said, split and signs. Put an X in each. Now, I look at my last sign. It's positive. That tells me they're going to be the same. Now, are they both positive or both negative? They're both negative. How do I know? Because I look at the middle sign. Are you with me? So the last one tells me the same or opposite. And if they're the same, the middle sign will tell me whether they're both positive or negative. Okay? Now, I list the factors of 16. 1 and 16. 2 and 8. 3 doesn't go into 16. 4 goes in 4 times. Are there any of these sets that add up to give me 8? 4 and 4. Sweet. Factored. Hey, side note, this thing right here is a perfect square trinomial. Perfect square trinomial. Okay, just throwing that out there. Let's do another one. Looking at this one, are we okay the way it is? Sure? Yes. Is there a GCF? No. Is there a leading coefficient? No. So? Split and signs. Put 2 sets of parentheses, put an X in each. Signs are same. And in this case, both negative. Next, I list my factors of 12. Now, time out. I've been using nice small numbers now, but we're not always going to have these nice, easy small numbers. But watch this. I always start with 1 and a number. That's easy. 2. Does 2 go into 12? 6 times. Now, see, I'm never going to have to check any number between 6 and 12. I do my factors, or I list my factors this way for a reason. I start at 1 and I work my way up because there's no number between 1 and 2. Therefore, I'm never going to have to check any number between 6 and 12. Are you with me? 3. Does 3 go into 12? Yes, 4 times. I don't have to check any number between 4 and 6. And I know it's only 5, but we don't have to check. And then 3, there's no number between 3 and 4, so I'm done. When these numbers come together, I know I'm done. Are you with me? For example, let's say I had a number, I don't know. I'll stop right there. So go in that order. I'll show you another reason why in a minute. So now I have my factors listed. Is there any of those that come together to give me a 7? 3 and 4. 3 and 4. And I'm factored. Now let me ask you, what are my solutions? What are my solutions? What are my zeros? Yes. They are 3 and 4. Remember, we take the opposite of what's in there. Do you remember that? We talked about that in the past. Good. Let's try another. Oops. Let's try another one. Is there a GCF? No. Is there a leading coefficient? No. So, split in signs. Means 2 sets of parentheses, X in each. Now, this means I'm going to have opposite signs. So I can go ahead and put a plus and a minus. Does it matter which one I put where? No. Now I list my factors of 35. So I start with 1 and 35. 2, does 2 go into 35? No. Does 3 go into 35? No. Does 4 go into 35? Hey, do you know that no even number ever goes into an odd number?
That is very much.
So I don't really even have to check 4, do I? Because 35 is odd. Does 5 go into 35? 7 times. The only number I have left to check is 6. Does 6 go into 35? See how I'm done? Do you understand what I was talking about in the last one? That's why I go in order as I'm writing them down and I'm checking them. Is that cool? All right, so now my signs are opposite, so I have to subtract. Can I subtract either of these and get a 2? 5 and 7, right? Now, which one goes where? It does matter. The larger number gets the sign from the middle. So 7's got to be positive, and the 5 is negative. What are my 2 solutions? Sweet. We getting it? All right. Let's do one more. Uno más. Is there a GCF? Is there a leading coefficient? So, split in signs. 2 sets of parentheses. Put an X in each. Opposite. So I put a plus and a minus. Doesn't matter. List my factors of 50. 1 and 50. 2 and 25. 3. No. 4. No. 5 and 10. 6. No. 7. No. 8. No. 9. No. So that's it. Which of these come together to get me a 5? Larger number gets the sign from the middle. So the 10 has to be positive. Whoop, whoop. And that is factoring 101. You think you can handle it?
Sure.
All right. I've got some practice problems for you. Wish you the best of luck.